Good morning, everybody. This is Mike from Crc. I am quite happy you guys are joining me today because we're finally going to start creating our multiplayer game, the thing we've been talking about for so long. You are about to jump into a tutorial that is a couple of hours long, and I would say that if you are not sure if you're going to finish it, at least try to plan going to the half of it, because at half point in the tutorial, we pretty much have a good understanding on how the multiplayer system works in Unity, the lower level API. And at that point on, you can branch out and do your own thing, or you can branch out or just not do it at all and move on to part 2. So I am not saying that the second half of the tutorial is useless, it's practice, but in the first half, this is where we implement most of the theory, and this is where most of the new stuff happens. So, but if you don't plan it to make it to the end, if you just want to watch it for a couple of episodes, then try to get to the halfway point, because that's where you'll get the most out of this. Okay, so the way this is going to work is we're going to have two projects. One the server, and the second project is going to be the client. Now, if you're on for the long ride, if you're on for the game we're going to be making in the future, the client aspect of it, you don't have to do nice UI to it, you don't have to put so much effort in it. You still have to write the code, but you don't have to put aesthetic in it, because this client side is going to be dropped at one point. Once we make it to the game part, so the second part of the tutorial, not the second half of this first one, but the second tutorial itself, then we're going to dump the client we made here, and we're going to be using that game instead. And that game will be connecting to two different servers, including the one we're going to be making right here. So, it's time to get our machines ready. You guys are going to want to create one project for each. So, one for the server, and also one for the client. So in this episode, we're going to be doing both. We're going to start our server, and we're also going to start our client and make sure they have a connection going on. So we're going to establish the initial connection, the initial road, I like to call it, where our data is going to travel. So I have my Unity hub open right now with the create new project window. I'm going to go ahead and create tutorial_server, and I'll boot another Unity hub and create the client itself. Just so you guys know, I have the exact same project. In fact, that's the third time I do this project. I have it on my other screen so I can follow along, and there is going to be the least amount of downtime, so we're going to be doing information quite fast. I have my client. Let's create that as well. This is the layout I will be using, so this is based off the tall layout. If you head over to this place here, this is what I use. I make sure my project is in one column layout. And I also usually add a console at the bottom, so let's go ahead and do that since I am right here. That's the layout I use. So we have two projects going on right now. We have the client and also the server. What's going to happen is that I'll be working on both at the same time. Now, what I'll be doing right here is a layout like this. So this is what you'll see most of the time when I'm working on both things at the same time. Always assume that the server is on the right hand side and the client is on the left. I know this is, yeah. Or you can also check at the top here, if you zoom in, this is tutorial client and tutorial server on this end. If you want to know how I place my window like that, I hold my Windows key and then use my left and right arrow key, and I can move this around and dock it properly. Okay, it's finally time to get started. I will create a new scene under the server. Actually, I'll just rename this one for server. I'll do the same for client. And now we will create our server object. At all time, we need to have this server object running, and at all time, we need to have a client object running. These two are going to make sure that the connection is kept alive, and also we look for messages from the other party. This is done in a script actually, so let's go ahead and create a new script folder for both. Script folder for client as well. And on this end, on the server side, I will be creating a server.cs, and over here on the client, client.cs. Okay, just so you know, I'm not going to be doing that the whole time. This is just at the beginning when we set up our project. Let's go ahead and open up our server. So this is a server.cs. I've also opened client.cs, but what I'll do here is I will actually full screen the server, and we'll focus just on that one right now. So let me zoom on that, and let me touch a couple of points that we are going to be looking at in a second. So the way I will be coding today is in such ways that if we want to strip mono behavior at one point, which is going to be possible in the future, Unity is working on that. It's been on their roadmap to actually take their multiplayer stuff and put it as a library by itself. But as I mentioned, I will be coding in such a way that we can get rid of mono behavior quite easily. Note that the only reason we're using mono behavior in the first place is only because we want to have access to start, awake, update, and that's it. So obviously, you can decide to strip it out yourself right now if you know how to. Simply remove mono behavior, create a server object somewhere else, and the object that doesn't die, and create your own update loop in there. Now, I won't be doing that. However, I will go ahead and create a private void start, and this one will call a public function called initialize. So one day, if we want to get rid of the start, we simply have to call initialize. In fact, that's exactly what we'll be doing in the start. So, everything we're going to be doing to initialize this, everything that's mono related is going to be in here, in the start, and everything that's server related and that's by itself is going to be down there. Now, that's the only real thing we need to initialize right now. We only have access to start. There's one more thing, but doesn't really happen in our server. It will happen in our client. It's the don't destroy unload. Now, I'll do it just in case somehow I change scene in my server, but I don't think that's ever going to be happening. This will happen on the client, however, and we want to make sure the client object never dies in between scenes. Time to jump in the real meat of this tutorial, the network transport class. And we will start this off by just initializing that component that they use. I called it a component, definitely not a component, most likely a system. Okay, so we decided we'll be using this network transport system. Now we have to define how are we going to communicate through our roads. Now I like to use the example of a road in this case. Let's imagine that the network transport is a road. We're going to have to define how many people fit on there, how many lanes is there, and who's allowed to go through. Which is all thing we have to do right here in the initialize. First thing, the connection config that we'll call CC. It's a new class. We'll initialize it right there. But this is going to be our lane definition. So what type of lane is there? In the network world, they call it channel. So we're going to add a channel. Okay. If you actually take the enum that they give you, so QoS type, and then you hit dot, have a look at the tooltip, there's quite a lot of channels, so quite a lot of different lanes you can use. So imagine you have a message you have to send over to a server, whether that be authentication request, buying an item, updating my position. Just imagine you have to send one of these three messages over to the server. Now on your road, you're going to have a bunch of different lanes. You have as many lanes as you want. And one of them you can take, and it's going to be 100% sure that your message get across. Another is going to be maybe sure, you don't know if it's going to get across. Another one is all jammed up, many people are on it, you don't know in which order it will get to. There is a couple of different channel or different lanes in this case. As you can see, we're going to have a look at some of them. This one right here, reliable. Each message is guaranteed to be delivered, but not guaranteed to be in order. So you're 100% sure that your message is going to get across, you just don't know in which order. Which means this will be good for buying an item. Imagine you're running a MMO game, and the person is spending gold, and he expects to have an item back. So he goes to the vendor, he asks to buy an item, and then there's a confirmation, and it says, are you sure you want to spend 1,000 gold on this item? He clicks on yes. You don't want to be sending a message, after a confirmation like this, you don't want to be sending a message that might not get across. Because the guy already pressed on the confirmation message. This message has to go through 100%. So, in this case, you could be using a reliable. You don't care in which order it gets there. Somebody might be buying an item at the same time and this person might go through first. You don't really care. In both cases, they're going to have their answer and they will be satisfied. Now, there's another one down here called unreliable. This one, there is no guaranteed of delivery or ordering. This is the fastest lane. If your game only uses unreliable message, it's not going to get clogged, it's going to be super fast, but it's also going to be a little bit iffy sometimes. This one would be good for updating your position, because sometime the client might have a bad connection. Assuming he's playing on some kind of device, mobile phone, or he just have crappy internet, there might be some moment or some frames that he's not actually sending the information at the right pace. User has a choppy connection and you're trying to send him a message. It might take a while for him to receive it because he has like bad internet and there's going to be some delay there. You don't want to clog the whole server because of that person, so you're not waiting on that person to receive its message before you send message to other people. And in fact, by the time he receives that message, the one that actually is clogging the whole system, he might not even need it anymore. The position has changed and now he needs to have a new position, a newer position. So these type of message, they can be dropped without causing too much of a problem. And to be honest, it doesn't really happen so much anymore unless the person is really lagging and having disconnecting issues. So unreliable is the way to go every time you want to send information that is not crucial to be delivered, but it can still be crucial to your gameplay, such as position. Okay, having a look at our application, what type of lanes do we need? What type of channel do we need? We're going to be using reliable, and in fact, only reliable. Our application is really simple, but it's also involving user input on actual UI, so you don't want to make our message unreliable in case the message gets dropped. So let me give you an example. If the person tries to log in, he clicks on login, you don't want to have him not receive a response. He needs to have a response. He clicks on login, now he's expecting a response. If he clicks on the button and the message gets dropped somewhere along the line, he's going to be waiting for no reason, basically. And we also have some logic that's going to be locking the UI, so he needs to have a response, therefore the message has to be reliable. However, we don't need it to be in order. Other people could be logging in at the same time. If they have faster connection, they could go in. We're totally cool with that because if we make it ordered, it means that we'd have to wait for first guy to go through, have his response, and then we could filter the others. So in this case, reliable works good for us, and having it in a non-ordered manner is also very good. So reliable is the only thing we'll be using. Why is it the only thing? Because we don't have anything else, such as position update, or we don't have anything that could be on the unreliable loop. All the action we'll be having are basically required to have a response or required to be done once we click on the button. So before we go any further, I just want to point out that the add channel returns a byte, so you know exactly which channel you're looking at. This is a very good practice to keep it anyway. I mean, you don't need it in this case, simply because we only have one channel and we know that every time we're going to be receiving information, it's through that channel. However, you want to be keeping that somewhere. So at the top of my script, I'll keep a byte for reliable channel. Now just make sure I see that reliable channel is equal to the add channel function, the return. Next up, we have the host topology. This one, I want you to see it as a, let's add the CC in here, and then max default connection is going to be the max player, or max user count. Okay, so this one, I want you to see it as the blueprint of our server. The way it's going to work is that the server is going to have like a map of the whole architecture of our road, basically. So this topology is going to point out the fact that there's only one lane in this road and it can fit 100 players or something like that. Once we go on our client side, we need to have the same definition that the server has. So the topology needs to be the same on the client and also on the server. Why is that? Because if the client tries to take road that the server doesn't have, we're going to have a massive problem there and your code is just not going to work. Actually, you're going to get an error from Unity before that. So they need to have the same blueprint, the same architecture of those roads before they go any further. So you should expect to see the exact same code on the client side in a few. So this max user, I'll make that a private const int and I'll lock it to say 100% at the time that can be connected. This can go up to whatever you feel like, of course, as long as you can support it. Now what you've seen thus far is code that will be shared on the client side as well. We now enter the section where it's going to be server only. So server only code, starting from here. What do we have in here? We need to add hosts. So network transport add host. It asks for topology. We have it right here. It'll also ask on which port we want to be hosting this. So which port is going to open itself for us to connect to. So for that port, you decide basically, as long as you take something that isn't already taken by another popular application. So of course, don't use port 80, don't use port 443, use your own port. In this case, I'll be using 26,000, just like this. Okay, and we'll be adding a port right there. As for the IP, I'll put that on null so anybody can connect to me. We're not limiting our server to a specific IP or a specific IP range. Now, I've duplicated the line down here because we're going to be doing the exact same thing, but this time for WebSocket. And this is what allows us to actually run this for browser clients. So the server is never going to be run on a browser. That's impossible, right? You're not running a server through a page in your browser. But this will allow us to connect to it using a browser. So using Firefox, using Chrome, using Edge, anything that supports HTML5 in this case. However, the parameter is going to change a little bit. We cannot connect to the same exact port because that other port is expecting sockets, normal sockets. It's not expecting WebSockets. So we need to have our own port for web. So I'll call this web_port, and I'll put that on 26001. There we go. Now, just like before on the add channel, we receive a return value. In the add channel, that was a byte. In the add host and also add WebSocket host, we receive a int. We are going to keep track of this so we know exactly who's speaking to us. Is it a web or a standalone client? So I'll actually put that down there. I'll leave my cons at the top of my script. And this will be private int host ID and private int web host ID. We'll make sure to take them and put them in front of our function, just like so. And that's it. That's how we open two different sockets, one for the standalone and one from the web. One thing we'll do before we actually end this function is we are going to add a boolean, private boolean, just to know whether or not the server is started. So of course, I'm putting is equal to false, but it's there by default. We are going to say here is start is equal to true. Just in case something goes wrong at one point, we can shut down the server, put that on false, and we can stop listening for new messages. You'll see that in a moment. So this section right here with the start, this is mono behavior viewer. And as I mentioned, if you want to get rid of it at one point, simply get rid of that section in here and manually call initialize and also manually call the update, which we'll see in a moment. But before we go any further, it's always good to have a shutdown. If you have some kind of initialize function, it's always good to have a shutdown as well in case something goes wrong. I don't use it in this tutorial, however, it's still a good practice to have it here. So what really happens in the shutdown is that we're setting our is started to false, and we're also taking the network transport, and they also have a shutdown that will turn off everything in the net transport API. So it's basically killing the initialize right here. Just as a good practice, we are putting it in there, but we don't really plan on using it anytime soon unless something major comes up, and yeah, good. So this is what the server.cs looks like at the moment. We are going to add some debug.log in there because once we test this out, we won't have anything visual happen to us. So to keep track of where we are in the code and if something went wrong, we're going to start putting some debug.log. Nothing ugly, just stuff that is informative. So in the initialize over here, once we're done, I'll be doing a debug.log. Of course, this is totally up to you. If you don't think like you need that, go ahead and don't use it. But that's what I'll be doing right here. I will be saying something of the sort. So opening connection on port, this port, and web port, this port. Of course, this is a format, so I'll just send my value now. And it will look like that. Now if I go ahead and I run this, nothing is going to happen. Why? Because we don't have a server object. So let's go ahead and create our server object. Empty game object, nothing on it. At 0, 0, 0, we are going to add the server component. So add component, or simply drag and drop it. Okay, if we press on play now, we'll get our very first debug.log. Opening connection on port 26,000 and 26,001 for the web port. Good. Simple stuff. Hopefully you're following along. You're going to have a better idea of what's going on as soon as we complete this client. And this one's going to be quite fast, guys. Why? Because most of the code is right here. Let me actually do something quite drastic here. I'm going to do Control-A, copy everything, so Control-C, and paste it on this side. Now, let me make some space here so we can see what's going on. We're going to be changing the class at the top to client, and let's see what we need in this case. We're going to keep the max user. We need that to match the same blueprint or same architecture. We're going to be using a reliable channel, that's totally fine. Host ID, web host ID. In this case, we won't need the web host ID. The application itself will know, well, we'll only have one host. The application itself will only have one host on the client side. He's going to be connecting to either the standalone server or the web server. He's not going to have a definition of both. For him, it's always going to be the server itself. For isStart, that's totally fine. Now in the start, we want to make sure we never delete this client, and this is really useful for the client. I said it's not useful for the server because we're never changing scene on the server, but for the client, he will be changing scene, so we need to have this. Okay, in case we're running mono behavior, of course. Now, let's see what goes on here. Initialize, that's fine with us. He defines which lanes are on the road, that's also fine with us. Creates a topology out of that with our max user. Yep, right now everything matches the same exact definition as the server, and here is the server only code. Obviously that's not going to work. So let's have a look at the client only code now. And as you can see, I've deleted the web host ID. In this case, not going to fly with us. Now the add host is going to be quite different. We're going to be sending our topology, and then we're going to be sending 0 as a port. We are not expecting anybody else than the server to connect to us, so we're putting that on 0. We are not opening ourselves for peer-to-peer. Peer-to-peer, not interested in doing peer-to-peer. We're closing this up for everybody else but the server. Now, we need to do client-only code in this case. We need to connect to the server. Now at this point, we have to connect to the server. How do we know where to connect? Well, we use a famous IP address. Yay! Okay, so let's go at the top here, private const, string in this case, it's going to be a string. This is going to be the server IP. If I can type. Okay, cool. So, server IP. So, at the moment, and as long as we're going to keep on developing this product, it's going to be on the local host. So, 127.0.0.1 or localhost. Up to you what you put. I like to put this one. And this will basically mean that you're connecting to yourself. You're connecting to your own computer, which is going to be the case until we actually put this on a Linux machine somewhere else or a Windows machine somewhere else, whatever you prefer. We're going to go through both strategy at the end of the tutorial, but just know that this is at the very end of everything. Once we're ready to push and have that in a production environment, that's when we'll be changing the server IP right here. In fact, you could be putting that on public and changing it in dynamically. So there's that. Client will require this. The server doesn't really need to know what is IP in this case, so we need to have the server IP. Now let's head down here in our client only code, and this is where it's going to get a little bit tricky. So, network transport, we are going to use a connect function. Now I know there's a couple over here, connect as network host, connect endpoint. What you're really interested in is connect, and you don't really touch the other one. First parameter is a host ID. We have that just from above. Next up we need an address, so server IP, okay. Thus far everything's going well. And then we need the port. Which port are we using? Are we Are we a standalone client or are we a web client? So at this point, we don't really know. Let's assume we are standalone. So we're going to use port. The other one, 0 and out error. Okay, so the other one, basically, we put that on null by putting a 0 and out error. This is in case something goes wrong during the connection. They will actually fill in our error value, which is something we'll have to declare here at the top. Private byte. I believe it's a byte. Yeah, it's a byte. Yeah, so if something goes wrong during the connect, they will change the value of error, and then you'll be able to output it and know exactly which error this is. Quickly like this error byte you see down here, this is going to return you a number. So in case something goes wrong, you'll actually look at this error byte and see something like 6, and then you'll be like, oh, the hell is 6, right? You'll find that over here on network error. This is something you'll just Google. So type in Unity scripting API network error, and then you just count. So if you receive error code 0, nothing goes wrong. It's all fine. If it's 6, it's 1, 2, 3, 4, 5, 6. It's a timeout. So use this page right here if you get some weird stuff going on. So the one I see most of the time is a timeout, and also 10. So 7, 8, 9, 10. Crc Mismatch. That's when both architecture are not the same. So assuming you're adding one more channel on the client side, you're not going to have the same architecture, and that's what you'll get in here. Okay, back to our sheep. This is for standalone client. Now we're going to copy this over for, you guessed it, the web client. Okay, now obviously if we write it this way, first let's add the web port. Like so. If we write it this way, that's going to crash. We can't do a connection on both. So we have to check using a couple of different methods. You could be using application class in this case, or you can be using the preprocessors. So I like to use the preprocessor call. I'm going to go here at the very beginning of the line, type in an if. So if it is not, so if it's not Unity WebGL, let me put the exclamation sign in front, and we are in the Unity editor, then it means that this is going to be the standalone client. Else, and then we do end if here. Okay, so what did I do right here? I've added a call that checked if we're not in WebGL and if we are in the editor. If we're not in WebGL, it doesn't mean that we're going to be in the web client, or it doesn't mean that we're going to be in the standalone client, because what happens here is this is the platform we actually target. As soon as we go on our client project and we switch the platform, and we'll do it right here as we speak, if we switch this platform over to WebGL by doing this, then this condition right here is met if we are targeting Unity WebGL, but we're not in WebGL at the moment. We're in the Unity editor, and we're still not in the browser. So that's why I added the and Unity editor on top of that, which means that right now, I got my logic wrong here for a second. Okay, so let me start over again. If we are in Unity WebGL and we're not in the editor, then in this case, yes, this is going to be for standalone. So I also got that wrong. Let me change space. Okay, there we go. Now this makes sense. Okay, let's have a quick review here because it's a little bit confusing. If we are targeting WebGL, which we are right now, and we're not in the Unity editor, which means if we're targeting WebGL and we're in Chrome or in Edge, then we are going to be using this code over here, which targets the web port, and that's good. Now, else we're using the standalone client. Now I just want to point that out again. Since we have now switched over to WebGL, we need to have the end statement, else this is what happens. When I remove it, as you see, this one got highlighted because we are targeting Unity WebGL. Therefore, it just thinks that our logic here is fine. It actually is fine. That's what we're targeting. But we also gotta say that we're not in the editor. Okay, this concludes it for the client side, at the exception of our debug.log, which obviously is not required for it to work, but we're going to change it, of course. We're going to say something of the sort. So attempting to connect on, and then we'll use the server IP, 0, and maybe add a triple dot here. So let's kill one of our parameter and say this is server IP. Okay. We could also add another debug.log in there just to say which platform we're on. So connecting from standalone or connecting from web. Connecting from standalone. And I don't need to have any parameter in there, so I don't need the string.format. And here is connecting from web. Let me get rid of the string format here. There we go. This one, and we are now good to go. Right. So this is exciting. Let's go in the client and create our client object, and then we're gonna try and run this, see if we have something going on. So I'll just type in client, drag and drop my new object on it. Hit play on the server first. Let's see what goes on. So he's opening port here, that's cool. Now we're going to hit play on the client. This one will be attempting to connect, or connecting from standalone, okay, missing an A. And then he's attempting to connect. We don't know what's going on, simply because we are not there just yet. We just know that there was an attempt. Now this ain't really interesting, simply because we don't even know if they managed to connect. I know they've connected, but to prove it, we're gonna have to head over to the next episode, guys, in which we're going to be listening to the messages we get sent, and those messages include connection, disconnection, and also any type of data you want to send through those roads. So that is it for our first episode. Hopefully it's a lot clearer explanation. I hope that you guys understand a little bit of what's going on at least. So I'll be leaving you guys today on this cliffhanger. Is it working or is it not working? We'll know in the next episode. As always, if you enjoyed the fact that I'm doing a multiplayer tutorial, the information is quite scarce out there. If you enjoyed that, please let me know, leaving me a like, leaving me a good comment in Discord or in the description down below. And yeah, catch you in the other one.